This is a problem in which we're going to be able to do some conversion back and forth between linear quantities and rotational quantities. And this one says a 29er is a mountain bike with 622 millimeter diameter wheels. It's kind of strange that they're called 29ers because they actually don't have 29-inch wheels. 622 millimeters isn't anywhere close. Of course, that also measures the inside diameter to the inside of the rim, not all the way out to the edge of the wheel or the tire, so that might make some difference. Anyway, if the back wheel of the bike is turning at 120 RPM, how fast is the bicycle moving along the trail? So we need to, again, as usual, write down what we know in this problem. And in this problem, we know that we have a diameter of the wheel of 622 millimeters, but let's recognize, millimeters, let's recognize that's got to be in meters. So if we move the decimal point over, that's 0.622 meters. And we have 120 RPM, so that's going to be an omega. Omega is 120 revolutions per minute. And I would invite you to stop and do the conversion of revolutions per minute to radians per second. And when I did that, I got 12.6 radians per second. Okay, and the question is, how fast is the bike moving along the trail? So that would be a velocity. V is what we're looking for. So if you look through your equations, you're going to find, I think, that we've got this equation, the one that we can transition from linear and angular velocity. We take the linear velocity, that will be equal to the omega, the angular velocity times r. And you know, we can just plug these numbers. We've got omega, which is 12.6 radians per second. And yes, we don't have r, but we can take the diameter and divide it by 2, 0.622 meters. Divided by 2, and I would invite you to stop now and put pause and see what you get for an answer. But I get 3.9 meters per second. And if you do some conversions, you'll find that that is about 10 miles per hour, which would be a reasonable speed for a bicycle on a mountain bike trail.